Question 7. Chlorine is added to decrease numbers of microorganisms in water. When chlorine is added, there's a redox reaction shown by the equation to reduce the oxidation state of chlorine HClO and oxidation state of chlorine HCl. So we're trying to find the oxidation state of chlorine in HClO. In HClO, it's going to be +1 because hydrogen's +1, oxygen's -2. -2 plus 1 will give me -1, and therefore chlorine must be a +1 to get an overall charge of 0. And then in HCl, well, that's going to be -1. Hydrogen's +1, therefore to get 0 we need a -1. So HCl equals +1, oxidation state of chlorine +1, HCl oxidation state of chlorine is -1. HClO +1, HCl -1. Then it says give two half equations, show the oxidation and reduction process that occur in this redox reaction. So we've got Cl2 plus 2H2O, arrow 2HClO plus 2H plus 2E minus. And then we've also got Cl2 plus 2H plus 2E minus, arrow 2HCl. And then we've got this equation. Chlorine is reacted with cold aqueous sodium hydroxide. In the manufacture of bleach, given equation for this reaction between chlorine and sodium hydroxide. So Cl2 plus 2NaOH, arrow NaCl plus NaClO plus H2O. If there's one equation I'd recommend to learn in question 7 from this video, it's this one. This came up on my mock. I'm pretty sure it came up last year exam, and I think it might have came up on my resit as well. It always pops up, this one. Chlorine reacting with cold aqueous sodium hydroxide, the manufacture of bleach, and I always get it wrong. I'm pretty sure, yeah. So Cl2 plus 2NaOH, arrow NaClO plus NaCl plus H2O. Cl2 plus 2NaOH, arrow NaClO plus H2O. And then 7.4. And we also got 7.5. 7.4. We want to find out the mass of potassium iodide need to react with all the ClO minus ions in a sample of bleach. First things first, what can we find out the moles of? We can find out the moles of Well, we can find out the moles of ClO minus. Moles of ClO minus. How do we do that? Well, we're going to use the equation moles is equal to concentration times by volume. So it's going to be 0.0109 times by 20, but we need it in moles per dm cubed, 20 divided by 1000. That'll give me 2.18 times by 10 to the power minus 4 moles. Then it says then what we want to find out, well, we can find out the moles of potassium iodide now. because it's a 1 to 2 molar ratio. So we're just going to do 2.18 times by 10 to the power minus 4 times by 2. And that will give me 4.36 times by 10 to the power minus 4. And now we can find out the mass of Ki very easily. Potassium iodide, because we know moles in mass of Mr, mass is moles times by Mr. 4.36 times by 10 to the power minus 4 times by Mr, potassium iodide, so Ki, so 4.36 times by 10 to the power minus 4 times by K and iodine, so K 39.1 plus iodine 126.9. I'll get 0.072376 grams, but we want it in milligrams. There we go. So to go from grams to milligrams, we need to times by 1000, and to go from milligrams to grams, we need to divide by 1000. But we want to go from grams to milligrams, so we need to times my value by 1000, and I get 72.4 milligrams. The observation, well, it's potassium iodide, so the colorless solution turns brown, or you could just say turns brown, because remember iodine. So what do we do? Let's go over it again. Find out moles of ClO minus using concentration times volume. Then we know it's 1 to 2 molar ratio, so times it by 2, we got the moles of Ki. Then we can find out the mass of potassium iodide, moles of mass of Mr, mass is moles times by Mr. Find out the Mr of potassium iodide in the periodic table, and then just read the question properly once it's in milligrams. So to convert from grams to milligrams, we need to times by 1000, and then the observation, and then give it to appropriate number of significant figures, 72.4 milligrams. Then the observation, it turns brown. Solution 7.5. Potassium chlorate is used in fireworks. Potassium chlorate decomposes, produces potassium chloride and oxygen. Give an equation for the decomposition of potassium chlorate. So KClO4 is going to decompose to KCl, and what else? Plus, we're going to also need oxygen, right? And how many oxygen we need? We need 4, so it's going to be that. So KClO4 arrow KCl plus 2O2. And then use the data in table 3 to calculate the enthalpy change for this reaction. Now, it keeps going up. It doesn't tell us. Does it tell us if whether it's formation data or not? It doesn't directly tell us. However, you look at the table 3, you have that F sign, so that tells me that's going to be enthalpy of formation data. Therefore, we're going to use the equation delta H enthalpy of products, and that's really key, because if you use the other equation, enthalpy of reactants minus enthalpy of products, you get the answer completely wrong. And you lose a mark. So, because formation data, enthalpy of formation, so it's going to be delta H enthalpy of products minus reactants, enthalpy of products for what we're producing, KCl minus 436 plus enthalpy of 2O2, or 2O2 because it's element by itself is going to be 0. Doesn't give us in the table, but we should know that it's 0. So it's a quick, just to try to trick us out, and then minus KClO4 because that's enthalpy of reactants, minus 434. So we get delta H equals minus 436 minus 434. Delta H equals minus 436 plus 434, 2 negatives become positive, delta H equals minus 2 kilojoules per mole to power minus 1. Enthalpy change is minus 2 kilojoules per mole to power minus 1. We got the decomposition, reaction, and then we can see that tiny f's formation data, therefore we use delta H as enthalpy, products minus reactants, and then substitute values in and you get minus 2 kilojoules per mole to power minus 1. That's the end of question 7.